My name is Hong Song. In this video, I'm going to present the Agile software development. With this, you are going to do the term project. Software development, it's also known as software engineering, is a relatively recent discipline within the computer science. And the IEEE Computer Society defines what software engineering or development is as follows. It is a systematic, disciplined, and quantifiable approach to the development, operations, and maintenance of software, and the study of these approaches. And in other words, that is called the application of engineering discipline to development of large-scale software. So it's a systematic, so there is a step-by-step structured mechanism within that, and it is a discipline. That means that through training, many people can attain to that. It's quantifiable, means that it's not just the abstract concept, it's quantitatively measured. So in the end, we apply engineering to software. Difference between science and engineering is science is pursuing theory and principle without any noticeable exceptions and the like. But engineering is to make things useful for user. So in larger scale software development, we are going to make the software usable in our daily life. So we have two models of software development. The traditional and the classical model is a waterfall, and then the one recently taking many attractions is Agile software. So waterfall model is a sequential process, which means that stage should be completed before you go to the next phase or next stage. And as water flows from higher position to lower, and then the water never goes back. So in this waterfall model, you never go back, just complete the given stage and then go to the next stage. So structure is the main focus of this model. The Agile is not the name of a specific approach, but is an overarching term that includes non-sequential or iterative processes. So one of the examples of Agile is extreme programming or Scrum and many others. So waterfall model have 5 phases. Requirements analysis, you get the requirements of the software to develop, and then you design, which is prior to actual coding, design the architecture and the many other things. And then you write the code, and then you test, and then you may release, and over the time you may need to maintain because a new problem is found or new features are added and so on. So here in classical waterfall model, you have to complete the stage, and then you go to the next stage as water flows from higher position to lower, as water never goes back, so you never go back. That's a waterfall model. Actually, waterfall model is adopted from manufacturing idea. Is that in manufacturing, for example, car, you just collect the requirements of the car you want to design and make, and then you make designs for that, and then you actually manufacture it, and then you have some testing for the product, and then you may update the model next year and so on. So here you never go back. Once you produce the car, you never go back to design. So that's the idea. So it just flows from one phase to another phase. The assumption of a waterfall model is that of late correction dramatically increases. That's the basic assumption of a waterfall model. What it means is that if you find something wrong in requirements, it's easier to fix and the cost is very low. But if you find some problem, once it's all manufactured, then changing something is very costly and very difficult. In car industry, that is called a manufacturer recall. As you know that if you do recall, it's a very costly process. So you want to discover the error or problem as early as possible, because of the cost of a correction increases dramatically towards the later phase. However, in software, the situation is quite different. The waterfall model in software development is adopted from the manufacturing industry at the early phase of computer ages. Compared to the computing system 4 years and now, there's a huge changes. For example, in terms of storage, 4 years ago, all the storage is within the computer system, so huge computer storage are very costly, and sometimes it's very prohibitive in practical use. But now, we have a cloud storage. Cloud storage is very cheap. And at that time, 4 years ago, computer was very slow compared to what you have now. The smartphones you have with you now, if you take it back 4 years with a time travel, then your smartphone now could be a supercomputer at that time. So that's computing power changes over 40 years. In terms of price, 4 years ago, computer is not for personal use, so only big size business can afford that. A personal computer was out of imagination at that time, but now a typical computer science student has more than one computing devices. You have a laptop, some of you have a desktop as well, you have a smartphone, you have a tablet, you may have some gaming console and the like. So price of a computer is very cheap compared to 4 years ago. Development environment at that time was pretty much depend upon the program. So you should do everything yourself. Tools are rarely available except for editor to write the code and compile. Almost all things are done by command line and the like. But nowadays, we have a huge and rich set of development tools. Some of them automate some typical process and so on. So using IDE or frameworks and so on, now you can do rapid application development. So those are changes in software environment over the last 4 years. So the development model, a waterfall model, is based on early ages of computers. And then situation might be quite different now. One of the basic assumption in waterfall model, as I told you, is the cost of late correction dramatically increases. But in nowadays, the computer environment is pretty different. So we have a new assumption for new development models, Agile models. First, changes are very easy using automated tool or IDEs. Editing some code or change is not very difficult. And then tools, practices, and principles are properly used. Then the cost of change can be flat over project time. The cost in the requirements phase, a cost to fix in last maintenance phase may not be hugely different. So if the cost is flat, then upfront work is nothing but a liability. So in early phase of development, if any ambiguity is there, don't make a decision, but delay it for the later part until you get the concrete data for that. So there is a value in waiting. But this was not possible in waterfall model because of the cost of a correction increases dramatically towards the later phases. But in the current computing environment, assumption could be the cost would be flat. Then we may find a new model of software development. So Agile method aim at flat cost. The emphasis of Agile methods is a focus on the code, especially running code, and the focus on people instead of the requirements process. And the emphasis is an iterative approach. You can go back to a previous stage as many as you need. So there's nothing you can do completely in one stage. Just do as much as you know and then move to the next stage and then do it. And then if you need to go back, just go back. So iterative approach is the main emphasis. And the customer is involved in Agile method. In waterfall model, typically customer make contracts with the developers. And developers goes by the contract. But in Agile method, you don't know. You make a contract, but during the development process, you get closer relationship with the customer, and the customer make decisions, some changes that can be done very easily. And the expectation that requirements will change. In the waterfall model, you begin with a contract and everything is done written in requirements. And then the remaining phases, just developers use the contracts are written in specifications or requirements and so on. So it will not change. But in Agile, simply assume that you may not get the complete, precise set of requirements in advance. So the requirements may change over the product development phases. And then we are going to accommodate that changes. Simplicity is another emphasis in Agile method. Instead of developing complex system, just make it as simple as possible by doing what the software needs to do. So comparing waterfall and Agile, waterfall is a prescriptive, means that waterfall process has instructions at each stage what you need to do. But Agile is all abstract. And the waterfall requires extensive documentation because you complete one stage and move to the next stage. So each stage should produce a precise documentation so that based on that you can move to the next stage. But Agile documentation is minimalized. Waterfall, sequential, as I told you, but Agile is iterative and continuous. Waterfall is formal, but Agile is informal. What it produces as a running code is more important than any documentation. It's process focused, but it's communication focused. Waterfall is gradual change from stage to stage, but Agile accommodates rapid changes. A group of software programmers gathered together and they declared something called Manifesto for Agile Software Development. Here is the declaration. We are uncovering better way of developing software by doing it, helping others to do. Through this work, we have come to value individuals and interactions over processes and tools. Working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is a value in the items on the right, we value items on the left more. So that's a declaration for Agile software development. In Agile methodologies, we have several popular ones, like extreme programming, what is emphasized here, and founders are listed here, Scrum, and many others. In our class, in term project, we are going to use a Scrum, and the XP and Scrum shares many common values and principles. So we will look into extreme programming briefly, and then we will study Scrum methodology in detail. Feature-driven development and the dynamic systems development method, and the lean software development, and the Kanban method. And then family, they are some of the popular Agile method. So let's begin with the extreme programming very briefly, and then we'll move to Scrum methodology. So extreme programming, the founder is Kent Beck. He defined extreme programming as follows. Extreme programming is a lightweight methodology for small to medium-sized teams. It's like around 10 people developing software in the face of a vague and rapidly changing requirements. So values and principles is communication. So we want to communicate as much as possible with the customer and within the team members. And the simplicity, we want to pursue simple implementation of whatever is required instead of a complex, fancy, luxurious implementation. The feedback, we want to get the feedback of any feature as its development and release it as soon as possible. Sometimes the customer is on site, so you get the feedback immediately from the customer. And then courage. In the waterfall model, you have a specific plan, so you just follow the plan. Each stage is completely done and you move to the next based on whatever you have completed. So even if you have some brilliant new idea during the development phase, it's hard to apply that because you need to simply follow the plans. But in extreme programming, since you are going to test, implement, release it pretty much a daily basis and the like, so whenever you have some brilliant new idea, just try to see if it works. So courage is one of the values in extreme programming. So requirement engineering in extreme programming is a customer list the features of the product you want to develop. So that is called the user story part. And then from the user story, developers pick up some top prioritized one and then make it task to complete it and the like. So in extreme programming, one of the very interesting features is pair programming. So typically, two members are paired together and then create a program. Typically, one member writes code while the other member watch over that. The reason why we do this one, if you get involved in writing code, you can see the details of that part, but it's a little bit difficult to see the bigger picture of the entire software you're going to develop. So the other guy watching over, you writing code can see the bigger picture, so can advise or guide and so on. And then sometimes they take turns to the other role and the like. So pair programming is one of the very interesting practice in extreme programming does. So with one computer, you have a mirrored screen so that you can easily see what other guy is doing and the like. Another interesting feature is on-site customer. So you have customer involved in your software development so that you can get instant or immediate feedback as soon as you finish one of the features and so on. So extreme programming is summarized as follows. Frequent release, sometimes daily release. So you release the software every day, something like that. And then test-driven development. What it does is that but before you write the code for a certain feature, you write the testing code first, and then you develop code to satisfy the test code. So that's called the test-driven development. And the extreme programming utilizes the TDD, test-driven development, widely. Pair programming, as I told you, and then daily build is encouraged. So you want to release the program every day, the like. So Scrum is sharing many common values of programming, and then this is the one you are going to use in your term project. The terminology Scrum comes from the rugby. So in Scrum, we have several terminologies. So we are going to study those terms in detail, but just to introduce you, the terms we may use is time box, is a specific duration during which a project is organized. And sprints is a work requirements grouped into chunks of work that can be completed in 1 to 6 weeks. So you can imagine sprint as a time period. Just imagine time period. And then that is 2 weeks or 1 week in your class. In Capstone class, it will be 2 weeks. But other than Capstone, such as mobile app programming or web server programming, a sprint will be 1 week. So at the end of each sprint, 2 weeks or 1 week, new functionalities to be released. So what it means is that if you are in Capstone class, every 2 weeks, you need to release the code. It may not be completely done, but some of the feature you should complete within the sprint, and then you need to release it. And then incrementally release it, then at the end of this project period, you will be finishing the entire project. So one of the most important thing in Agile is that you need to deliver working code at the end of each sprint. So if you are accustomed to say that in this week I have done much of the back-end design, so I don't have any running code yet. In Agile method, that's a failure. So do not use it such as an excuse. So if you need to do some back-end design, do that, some of them, but don't just focus on back-end design only. Always write the code which uses whatever you did in the back-end. And then show that the running program is there always at the end of each sprint. And product backlog is software requirements. So system requirements, software requirements will be written in the form of a user story. User story is a one English sentence with some specific component. We are going to study that shortly. So product backlog is a specification of the software to develop. In other words, it's a requirement. And then requirement is written in English sentence called user stories. And daily Scrum is a team meeting. And then in professional world, you will have a daily based meeting, very short meeting. But in our environment, it's just a project of a certain course. So I don't think you can meet the basis. So I will just require you to meet at least 2 times a week. Twice a week will be requirement instead of a daily meeting. So what you do in Scrum daily meeting is that you report what you have done yesterday, and then you say what you are going to do today, and then discuss any problems. So the daily meeting will be very short. Burn down, burn up chart is to trace the progress of the project. So here is a flow in the Scrum software development. First, the customer asks you to develop software. And there might be some stakeholders for the software to be developed. But for convenience sake, you may have many customers. So for convenience sake, you will have one person as a product owner that represents the entire customer or stakeholders. So product owner is not a software developer. The software developer is here. So you will be in one of the team members here. Product owner has the requirements of the software to develop. So requirements are written in product backlog. Product backlog is written in user story format. User story is a one English sentence which has a specific format. We will see that shortly. So you have a list of user stories that is called the product backlog. So ideally, product owner creates requirements of the software to develop. And this product backlog, those user stories are prioritized. That's the most important thing on the top. Then what the software development team does is for each sprint, 1 or 2 weeks, the team picks up the top prioritized list. Just take them out, and that part is called the sprint backlog. So the team will work on sprint backlog for a given sprint. During the sprint, 1 or 2 weeks, teams meet every day, but in your environment, you may meet just twice a week, and then the meeting is operated or arbitrated by a leader. That leader is called the Scrum Master. The Scrum Master is a team leader. Just terminology. So team leader does the daily meeting and then check the progress of the team members. And at the end of each sprint, the development team releases a software working code so that stakeholder or product owner can review whether that feature has been done or not. So either accept or reject, and then continues the next sprint and so on until you finish that. So you have here you have several role players are there. So you will be the team, software development team. One of them will be leader called the Scrum Master. Product owner creates the requirements of software, but in our class environment, there will not be any person outside your team to create the requirements of software you develop. So you are going to propose what kind of software you are going to create. So one or more of your team members will share the role of a product owner at the same time. Okay? So product owner is not outside your team in our class environment. So one or two or more people can share the role of a product owner. And stakeholder review the product owner does that. So within your team, everything should be done. So one of you will be a team leader. So product owner in a real environment is that someone who has a vision for software to develop, and then the product owner conveys that vision to the development team or collaborates with the development team. The product owner owns the product on behalf of the company if a company wants to produce or develop some software. And facilitate product decisions. What it means is that the product owner has a final authority, say what kind of a feature the product should be developed, or once the software is done, the product owner has a final authority whether to say it's acceptable or not acceptable. The product owner is responsible for creating and maintaining software requirement called the product list. So product backlog. Product backlog is turning the product vision into actionable project accomplished by creating and maintaining the product backlog. So product backlog contains all of the requirements for the project. And the requirement is written into user story format. We are going to see that shortly. And that's the market, competition, and customer expectations change. Product owner can easily react by changing the priority of the user stories or adding or editing those ones. So responding to changes without disrupting the whole development process is a value of Agile method. At the end of each sprint, 1 week or 2 weeks, depending on your class, so you are going to deliver the working code, and the product owner whether accepts it or rejects it. If the result does not meet the owner's expectation, it should be put it back to the next work to do, or some new user story may be added to make it clear. And so, Scrum Master is a team leader, so it's responsible for leading the development team, and willing to make decisions, actively work with that, and so on. So responsible for sticking to the principle of a Scrum Agile method, and hold the team accountable for honoring their commitment. If it's not completing the testing or some other things, the Scrum Master should work with the team to improve the performance. So Scrum Master is a typical leader and take the responsibility of those leading the development team. And in the team, in Scrum environment, we begin with a team working agreement. The Scrum team is full of talented people who will ultimately deliver the project. So it's very important that the team operates with trust, transparency, and teamwork. One way to do is create a working agreement. So working agreement is a set of expectations. And it's just more than simple rules of engagement, but it's all values and commitment should be there. So what topics in working agreement should include is time and location of a daily Scrum. So in your class, you are required to meet twice a week, so you need to define or agree when to meet, where to meet. And testing strategy, you should agree that. And then infrastructure plans, you should agree that. And what kind of ID do you use, what kind of source code control system you use, and the like. And then some ethics and moral of the team, coming on time, and they respect estimates and help when needed, and so on. And then you should also include how to address bug fixes or fires during the sprint. In a real environment, as I told you, product owner is not one of the team members. So you should have some idea how to contact product owner, because remember that product owner has the final authority to accept or reject the result. So whenever you have something ambiguous or something clarify about the software development, you may need to contact the product owner to clear or clarify those issues and so on. Also, capacity plan for initial sprints is included in the working agreement topics. So Agile requirements in Scrum is a typical principle and values for all Agile. So here's Scrum. Instead of documenting all of ins and outs, Agile calls simple instructions. Requirements are focused on meeting the need of the user, delivering the tangible business value, and inviting collaboration. So requirements are written in terms of user stories. So user story is one complete English sentence of the feature of the software. So user story must be small enough that can be designed, coded, and tested within the sprint by one member. Since the length of the sprint is short, 2 weeks in Capstone class, 1 week in mobile apps or web server programming, the user story is forced to be simple and concise so that one member can accomplish within the sprint. The user story contains of several components, but in our class we will focus on those 3 components. So those 3 components are mandatory in each user component. And then as the name implies, the user story is a perspective as a user, from the user's viewpoint. So user's viewpoint, how the software works, that's user story. And then in a typical software, there might be several users. Like a typical website, you say that as a registered user, as an unregistered user, as a site administrator, and the like. So if it's a site administrator, if it's a registered user, what he or she wants to do and why he or she wants to do, and that should be specified in one complete sentence. And that's called user story. Also in mind that user story should be simple and concise so that one member can implement that feature within each one sprint. That's the user story. So user story has this format. As a type of user, I want what, so that why. So those 3 components should be specified in the user story. So as a type of user, so that user is the viewpoint. So user viewpoint of administrator, the viewpoint of unregistered user, and so on. And then that one should be specified here, and then it gets you some idea of what kind of software you should write for that. So it is important for developer to understand the perspective of the user, whether technically advanced user or challenged user. And then in a game programming, typically user is just gamer only. But using gamer only to describe the entire program is a little bit challenging, so it's okay to personify each game character to write the user story. What I mean by that is if your game has a UFO, then in addition to as a gamer has a viewpoint to see how UFO appears and how it gets destroyed. Also, it's easier to specify the game from UFO's viewpoint as well. So it's okay to do as a UFO I want to and the like, or as a missile I want to. That's also acceptable. So here I want to do what? So goal of this user story is specified. Of course, that's what you need to write the code for that. And then additionally, which is also a very important part, is why you want to do that as that type of user. And understanding why the user wants to accomplish something gets you more criteria for developing software. So let's just see some example. So user stories. As a concerned and retired grandma, I want to receive weather alerts for areas where my children and grandchildren live. So that reason is I know when I need to worry and call to make sure they are safe. So we have a who part, an old woman. So based on that, you have a more specification for the software. That is, user interface must be simple for typical old woman. And then you may give a bigger buttons and fonts and so on. So that's you get some additional information based on who. And then what you want to do is specify. User wants to receive alerts of weather events in specific area of the country. So based on that, you have a further guideline what kind of features you need to implement. Also, very important one is a why part. This why part gets you prioritize some of the features and the like. So user wants to know when to worry. That's a why part. So based on that, so user wants to know when to worry so that if tornado alerts should be on a very high prioritized one to implement that. But like some allergy or pollen reports may not be. So you can deprioritize those things and so on. So why part carries some further information about the feature you need to develop. So to create a good user story, we have an acronym INVEST, so independent, negotiable, valuable, estimatable, small, and testable. So at this time, I want to pause this video and read each of those one carefully and think about that. Another term comes is epic. Epic is just a user story. But it's too big to be designed or coded or tested within a single sprint. Why do we have such a step? At the very beginning of the software development, as I told you, you collect all user stories, which is a requirement. At the time of writing user stories as a requirement, it may seem to be a very small one, but by the time you begin writing code for that, you find it's too big. Then that user story is called epic. Epic is like iceberg. What you see is only 10% over the surface of the water, and the 90% of it is hidden. So by the time you write the user story, you only saw 10% of that, but if you actually begin working on that, you find that many other things are there, hidden, and so on. So then what you do is epic into many child user stories. So epic and child user story, all of them are user story, but only the amount of work is slightly different. So why do we typically have a user story? As I told you at the very beginning, it seems small, but at the time of actually implementing the code, it seems that it's not that small enough, and you need to break that. Here's an example from our daily situation, not a software, but I will show you the another example in software development one as well. So here the user story is, as a host, I want to make Thanksgiving dinner so that my guests think I'm a good cook. So if you have a plan for that at the beginning of the year, towards the end of the year, at Thanksgiving Day, you want to do that. But if you thought about that in March, this statement that your user story seems small enough. It's good enough. So you just keep it as user story. Now October approaches or November begins. Now you want to do that. You want to plan for that, prepare for that. Then you find that this is just a too big statement. You need to break it down in several ones. For example, as a host, I want to bake pie, so that to bake my guests first. As a host, I want to cook turkey so that my guests has a main dish. As a host, I want to set my table so that my guests have a place to dinner. And what? You can break this user story into many small user stories called the child user stories. So this typically happens in software development as well. So at the very beginning, you begin with the user story, and the product backlog is a list of user stories. So all the user story in the initial product backlog may seem small enough, but if you begin working on that, you may end up breaking that into many pieces, many small user stories. That's called child user stories. So in software, suppose you are developing website. At the very beginning, this is user story. As a site manager, I want to update the product information so that site is always up to date. So that was that seemed small enough at the very beginning, prior to creating any website yet. But as you begin working on that, you may find that this one includes several features, such as a site administrator, I want to first see the list so that I can browse. Another one is I want to edit so that I can update it. Another one is I want to delete it to remove from the listing permanently, and so on. So this one user story may break into 3 user stories. So this is called the child user story, and this is treated as epic. Similarly, another user story at the beginning I had was, as a site administrator, I want to add new product. So the purpose of that is customers are aware of new ones. Then this may be broken into 2 at least. I want to add a new product so that new items are available. Also, I want to highlight the new item or current item. So the user story becomes big, so we break into 2 small ones, child user story. Here is another example. It's an example in game programming. So in a game, I have a UFO. So here at the very beginning, the user story is as a UFO. Remember that UFO is a game character, but you can personify as if it's a user, one of the users, so that you can create user stories easily or more practically. So as a UFO, I want to appear at a random position and fly horizontally back and forth, so that the gamer cannot shoot me easily. But when you begin writing code for that, you may find that you need to do several things for this one. For example, as a UFO, I want to appear at a random position of the scene so that gamer cannot guess my location in advance. Also, as a UFO, I want to appear at a random position of the upper half of the scene so that I always appear to be in the sky. And also as UFO, I want to fly horizontally back and forth so that gamer cannot shoot me easily. So these are user stories. And then this one is epic. As you create user stories, as you break that into child user stories to develop, you also need to create acceptance criteria. Acceptance criteria is a sense test plan. Remember, in the product backlog, you have a user story. In product backlog, you have a user story. But user story may become a epic when you begin working on that. Epic. So epic, a bigger user story, you break it into child user story. For each child user story, you need to develop acceptance criteria, whether the completed code is acceptable or not. That should be defined. So for each child user story, for example, if a child user story is as a business executive, I want the name of my saved searches to default to the city name, unless I choose to manually override it, so that I can streamline saving my searches. Suppose this is child user story, so you need to develop acceptance criteria to verify it. So in this child user story, we may have 4 acceptance criteria. First one is verify the correct city name is automatically populated when search found the location by city state and save option is chosen from mobile device. Another one is verify the correct city name is automatically populated when search by zip, or verify the default location, verify and so on. So for each child user story, you need to define acceptance criteria so that when the software is done, you can test it. So product backlog in Scrum. So to remember, product backlog is a list of features, is a requirement. To improve the product backlog quality, we can use a DEEP acronym, means detailed, appropriately, estimated, emergent, and prioritized. You may pause the video now to read each of those and think about that. Product backlog examples, you can find many of those from internet search. I have shown one of them, and I'll show you the template that you can use in your term project. So after this video, I'll post another video to explain the example or template product and sprint backlog. Here's the references I used for this video. One book, and some another book is here, and then some website for Agile method, and then some online video class from Udacity. So those are references.